Students, today's topic that we will be discussing is comparison of various SDLC models. So that means software development lifecycle models. Let's compare what is the use of which model and what are the advantages and disadvantages of various models. Now, first of all, it is what? SDLC is what? A framework that describes the activities that are being performed at each stage of a software development. So talking about the very classical model, the very first model that is also known as waterfall model, linear classical model, the various phases that are there in the waterfall model are requirement, design, implementation, testing, installation, maintenance and so on. So basically in few books these categories have been merged together, in few books they have been further differentiated into various phases. So broadly when we talk about the requirements, it defines the needs of the required information in order to develop the system. One should understand the functions, behavior, the performance and the interfaces required in the system. Then in the design phase we are talking about the data structure, architecture, interface presentations, algorithms and so on. And finally when we are going to implement it, we will be talking about source code generation, database generation, documentation and the testing part. Now since we are trying to compare these models, so let's talk about the strengths of waterfall model. The waterfall model is very easy to use and understand because it is very simple and you have to go in a hierarchical or sequential manner and there is no moving back. So it is very simple to easy and understand. It provides structure to inexperienced staff. The people who are using the or developing the software for the very first time can easily follow this model. So we can say that the inexperienced staff can also use this model in software development. The milestones are well understood because only when the first phase is completed we can move on to the next phase. So milestone at each and every phase is very much clear to the user. The stability of the requirements is there. Since the user involvement is minimal, so the requirements are to be framed at the very beginning of the software only. So the stability is there. Good for management control, since the deviations, since the modifications or the change in the requirements cannot be incorporated in between the development phases. So it is very easy for the management to track and control the development of the software. It works well when quality is more important than cost or the schedule. Now talking about the disadvantages or deficiencies in this model due to which the other models emerged. First of all the requirements should be known in the beginning itself. But in real world scenario, it is very difficult to tell the requirements at the very beginning stage. In between also the requirements keep on changing. Second, the deliverables created for each phase are being frozen. That means if you are moving on to the next phase and you require some changes in the previous phase, you cannot do it. Why? Because it is already freezed. Next, it can give a false impression of progress. That means though the user involvement is minimal, but the management is tracking the progress. Maybe at the last stage, when you reach at the last stage, the management views it as if the project is being completed, but some changes were required as the user is not involved. So it was giving us the false impression, yes, the progress is okay and we are through with the project. So this is also a negative point of waterfall model. It does not reflect problem solving nature of software development. That means iteration of phases is not possible. Integration is one big bang at the end. Only the final product will be viewed at the end of all the phases of the SDLC model. And there is very little opportunity for customer to have a preview of the software. By looking at the advantages and disadvantages both of the waterfall model, let's see when we should use this model. It should only be used for small projects and when the requirements are very well known in advance. The product definition is stable. Technology is well understood by the people who are going to develop the project, and it is a kind of new version of the existing product. So porting an existing product to a new platform is much more easier, and we can use the waterfall model in this case. Next is the prototyping model. In prototyping model, what we do, we develop a prototype first and then show it to the customer, and once the customer approves it, we start making the final product. So in this also the basic steps are almost similar to the waterfall model. You have to identify the requirements first, what all inputs are there, what all outputs are there, and then you have to develop an initial prototype which is to be evaluated by the end user, and depending upon the review by the user, the prototype and the specifications can be enhanced and revised. Now, advantages of prototyping model: it reduces time and cost and can improve the quality of the requirement specifications provided to the developers because the customer is evaluating the prototype first, and only after that we are going to develop the particular project. Then improved and increased user involvement, so user can easily interact and have a preview of the final system, how it is going to look, and can easily give the feedback. So any miscommunications or any misunderstandings can be revealed at an earlier stage and sorted out. Now talking about the other side of the prototyping, that is disadvantages: insufficient analysis. Since the focus is on limited prototype, so it can distract the developers from analyzing the complete project, and sometimes it happens that more focus is given on the small area which is developed in the form of prototype, and it might overlook the better solutions that are also available. Conversion of limited prototypes into poorly engineered final projects that are hard to maintain. Limited functionality may not scale well if used as the basis of the final deliverable. So when we have to use this prototyping model, it can be used where regular interaction is required with the end user, and since the interaction is more in this, so the user and the computer or the final product can be developed in quick manner if the prototype is properly understood. So, and it is being specially good for designing good human computer interfaces. Next very important model is spiral model. The advantage of spiral model basically is the risk analysis phase that has been added to the model. So risk analysis and RAD prototyping has been added to the waterfall phases, and a new model has emerged that is known as spiral model. So each cycle in the diagram, you can see that each cycle involves the same sequence of steps as they were there in the waterfall model, but the risk analysis and RAD prototyping has been added to it. So talking about each and every quadrant, first quadrant says that you have to determine the objectives, alternatives and constraints of the project that is being proposed by the user. So in objective you have to mention the functionality, performance, hardware interface, critical success factors and so on. In alternatives you have to give whether you can build a new system from the scratch, or you can reuse the existing one, or maybe you can buy it from somewhere or give a contract to a third party. And when we are talking about the constraints, so cost, resources, interfaces, schedule, all these are the constraints to be determined. Next quadrant talks about the evaluation of the alternatives and identifying and resolving the risks. So you have to study the alternatives and identify the risk. Maybe there is lack of experience, or people are not aware of the technology that is to be used in developing the project. The schedule is too tight, resources are not there. So you have to identify the risk and try to resolve them at an earlier stage. Now talking about the strengths, advantages of spiral model. Now since the risk analysis has been included in this, so this is the main strength of spiral model. Moreover, the user can see the system at an early stage because of the rapid prototyping tool that is being incorporated in the model. Critical high risk functions are developed first. The design does not have to be perfect. Why? Because rapid prototyping is being developed, so we can have some space for changing the designing in each spiral. Users can be closely tied to all life cycle steps. Early and frequent feedback from the users can be taken, and the cumulative cost can be easily accessed. Talking about the disadvantages, now time spent for evaluating the risks is too large for small or low risk projects. So if the project is small one, then using the spiral model will be charging more overhead expenses, more resources will be required. So for small or low risk project, this model is not suitable. Now time spent in planning, resetting the objective, doing risk analysis may be sometimes excessive. The model is also very complex and the risk assessment expertise is required. If the people involved in risk assessment do not have expertise in this, then it might generate a problem afterwards. Spiral may continue indefinitely since it is going on and we are going on developing RAD prototyping model. So sometimes this cycle becomes indefinite if the expertise is not there. Now developers must be reassigned during non-development phase activities, and it may be hard to define objectives, verifiable milestones that indicate readiness to proceed through the next iteration. So when to use this model, it is very clear from the advantages and disadvantages. When creation of a prototype is appropriate, risk is involved, and basically the projects are of medium to high risk, requires high risk evaluation, long term commitment, and users are not sure about their needs at an early stage. Requirements are somewhat complex, new product line is there, and some significant changes might be required throughout the development of the project. Now incremental SDLC model, basically it constructs the partial implementation of the total system and then slowly and gradually keep on adding the functionalities. So that is why we call it incremental model. So the requirements are prioritized and then implemented one by one. So what are the advantages of this model? It develops high risk major functions first, since the priorities are being sent. So high priority functionality is firstly implemented. Each release delivers an operational product. Customers can respond to each build. Now it uses divide and conquer policy, lowers initial delivery cost, product delivery is faster, and customers can get the important functionalities implemented at an earlier stages. Now when we talk about the other side of the incremental model, that is the weaknesses, it requires good planning and design. It requires early definition of a complete and fully functional system to allow for the definition of increments. Well-defined modules, interfaces are required, and the total cost is also not very less. So when to use this model? Risk, funding, schedule, program complexity, or need for early realization of benefits is there. So whenever these parameters plays a crucial role in the project development, this model can be used. Moreover, most of the requirements are known at an earlier stage but are expected to evolve over a period of time. A need to get basic functionality to the market early. On projects which have lengthy development schedules and which are using the new technologies. So this was all about the basic comparisons of the some important SDLC models. Thank you so much.